All right. Hopefully everyone can hear me loud and clear. So today we are going to look at cross-platform applications with Flutter. So mobile app development on both iOS and Android. If we first start off just by quickly going over the hack pack, which is available directly from the schedule on the Hack the North portal. There are some prerequisite workshop checklist stuff. So if you do want to actually follow along and code along to this workshop and get something up and running, you will need to make sure you have all of this stuff installed. And it does take a while to install. It's probably about 10 to 20 gigabytes of stuff, because not only is it the Flutter and Dart SDK, which is a couple gigs, it'll also be Android Studio, which is another couple gigs, Xcode, which is another couple gigs, and then the emulator, which is another couple gigs. So it adds up to about 15 to 20 gigabytes in total. But all good. If you never had the chance to set this up, you can still follow along to what's on the screen. It'll be recorded. And if you want to come find me later in the hackathon, I can help you get set up as well. All right. So we're going to get started just because of time. And again, this will be recorded and you can find me later if you need help with all of this. All right. So even though I already got an introduction, that's a picture of me. I am a University of Toronto computer engineering graduate and I guess entrepreneur as well. I've started my own company mainly just to avoid taxes. So yeah, I guess entrepreneur as well. And that's my Instagram. So feel free to reach out to me if you have any questions. I avoid LinkedIn nowadays because there's quite a bit of spam on there. All right. For the agenda, first we're going to start off with talking about cross-platform development, what it is, and why it's important. We're also going to spend 15 minutes on getting started with the actual application and running it. And then we'll spend about half an hour on expanding the application template. And then we'll spend the last 5 minutes talking about user interfaces and scalability. And then at the end, we'll have a Q&A and I'll stick around for anyone who needs help or has any questions for me. All right, let's dive into it. So cross-platform development basically means write once, run everywhere. So cross-platform development is basically a single application that runs on several operating systems while sharing code across platforms. So our goal is basically write the code once and be able to run it on all the platforms. These are the three major cross-platform tools that are out there and the most popular ones. You may have heard of them, you may have missed them, but today our focus is with the first one, Flutter, but we're going to compare all of them and why we're going to look into Flutter today. So Flutter is an SDK that uses the Dart programming language. It uses a custom rendering engine. So that basically means it runs kind of like a game. So I don't know if those of you are familiar with Unity, but Unity basically allows you to create a game that can run on the Nintendo Switch. It can run on your phone. It can run on Mac OS. It can run on Windows. And that's similar to how Flutter functions and is able to run across all the platforms. GPUs are pretty good in phones nowadays and just in general. And that's what Flutter really takes advantage of. It is supported by Google and the community as well. And it's a fairly new tool. Then we have React Native, which is probably the most popular one out of these three. And that's probably because it uses JavaScript and a lot of people know what React is and it functions, or not functions, but it's formatted in a similar way. React Native works a bit differently than using a custom rendering engine. It converts the components to native components. So for example, on iOS and Android, if we look at the switch is different and you basically say switch in React Native and it converts it to whatever specific switch is used by your host. It is actually abandoned by Facebook. Facebook started it and It was kind of a failure, so they left it, and it's all supported by the community nowadays. And it is a popular framework just because of the React nature to it. Then we have .NET MAUI, which a lot of you probably haven't heard of, but it uses the .NET framework, which is pretty popular amongst Windows apps, and it uses C#. So this is kind of similar to React Native, but it's a direct native component map, and it's supported by Microsoft in the community. However, because it's not widely used, there isn't a lot of information out there when you come across a bug, and there isn't much support available either. All right. So we've chosen Flutter, the first one, and directly from the Flutter website. Flutter is an open source framework by Google for building beautiful, natively compiled multi-platform applications from a single code base. And again, that single code base is kind of what we look for in cross-platform development. These are the advantages of Flutter compared to kind of everything else. So again, it has that custom rendering engine, which I've talked about before. GPUs are pretty powerful in phones nowadays, and it takes advantage of the GPU to basically render the application. It allows us to easily integrate platform-specific code. So for example, if we want to use the Bluetooth or camera of a phone, it's going to be different per platform, but we can easily write something that converts the input from that hardware sensor into Dart code. It also allows us to have a unified look across all the platforms. So because it uses like a game engine, we know that everything will look the same across every single platform. There's also a great component library. So that basically means that we have access to a whole bunch of different UI components right out of the box. We don't need to install any third-party component libraries, and everything's all done to the standards of each platform. So Material, for example, on Android and iOS has its own library as well, all built in right out of the box. Also has a strong community. So it has a public GitHub repo. I think there's about 9,000 issues on it, but it's actively worked on by everyone in the community. It's open source. And because of that, there are regular SDK releases made. All right. Now we're going to get started with Flutter. So we're going to first look at our development environment. So in the hack pack, there are a few checks that we want to make sure we can do before actually running our template project from GitHub. So we want to make sure Visual Studio Code is installed. We want to make sure Android Studio or Xcode is installed. Android Studio allows us to develop for Android, but it only is supported, it's supported on macOS and Windows, while Xcode, on the other hand, is only available on Mac, but it allows us to develop for iOS. So if you want to develop for iOS, you need a MacBook, but if you want to develop for Android, a Mac or Windows works. Then we want to run Flutter Doctor. So Flutter Doctor is a command, so we can open up the terminal, and we can go ahead and, oh, that's kind of small. Run Flutter Doctor to confirm our installation of the Flutter SDK. There we go. So Android has some issues, but Xcode is working great. And we also have working Android Studio, VS Code, and we have some connected devices available. So that's all good to go. And we also want to clone the template project from GitHub. So if we take a look at the hack pack, the template project is the last to do in the pre-workshop checklist. We want to make sure we clone this repo. All right. So now the template project. So the template project on the GitHub is a simple to-do list application. It includes basic routing. So every mobile application has a routing system, and I kind of wrote a custom one that makes sense to me at least, and kind of simplifies the whole what is built into Flutter. So it adds tabs and actually changing pages as well. And it adds a local database, which just use local storage for now. There are a few things missing. So it is a to-do list application. The to-do list task component indicated here, the thing that you actually check off is missing, and also our implementation of Gemini AI from Google is missing. So those are the two things that we will work on together. So let's first open up the project on GitHub to see everything that's here. So there's a README that is basically the hack pack summarized all in here. And when we download this, we'll be able to see that everything is located in the template folder. And then all of the source code is located within lib. So let me open it up in Visual Studio Code. So for those of you who don't know how to open it, we want to go to File and Open Folder. Then we can select the folder that we downloaded from GitHub or cloned from GitHub. And it'll open up everything here. So we want to open up the template folder, and everything is contained in lib. So we want to open up lib, and I'll just go through kind of how the project is formatted for now. So we have main.dart, which is open here. And as it implies, main.dart is the main application. Everything that starts when the application starts up is run here. So there are a few to-dos that we need to work on together, but it initializes the shared preferences, which is the local database, and then it initializes Gemini and it runs the application. So we can see that app right here is a stateless widget, which is right below. And this initializes some more things and runs the material app. So the material app contains the theme and everything that Flutter kind of needs to draw UI. And there are some other classes here that I wrote, such as the navigation framework, which we can control click to open up. We can see that the navigation framework contains a list of navigation tabs. And all of this stuff is written for you. I'm just kind of going over it in case you're curious if you want to add your own page. So say we want to look at what pages already exist. We can open up the lib routes and we look at tabs. So we can see that the tabs are declared here and the different routes are declared here. So if we want to expand the application later, we can just do that all here. And the template that is already written handles all of that. So this is just kind of the everything that's expanded out that kind of makes this application run. So let's actually run this application. How do we do that? Well, we need to select our device. So Flutter supports a whole bunch of devices. It supports macOS, Windows, Linux, Android, iOS, web, everything, which is pretty cool, but we're going to focus on running it on Android or iOS. So for now, I've installed both. I have an iOS emulator and Android emulator, but for this experiment, we're just going to run the Android emulator. So we can go ahead and select that. We can see that it starts to run. So we installed this Android emulator through Android Studio. And just wait a second. Sometimes it takes a second to turn on. So this is kind of just a full Android phone right here. All right, and then if we go back into Visual Studio, we can start debugging by going to run and start debugging. So we want to make sure that the Dart file is open before we're allowed to do this. Visual Studio recognizes that this is going to start a Flutter debugging session. So we can see down here, it's currently building the debug app, and this may take a while depending on your device because compiling is quite CPU intensive. You can give this a second. Does anyone have any questions so far? Yeah. Speak up. The code? Yeah, the starter code. Okay, I can show you how to get to it. So if you open up the Hack the North portal and you open up the schedule and then you click the cross-platform app development time block in the schedule, you should be able to see a link to the hack pack. Perfect. Awesome. And then the GitHub repo is linked there. Cool. All right. So our app started. We are in debug, and this is our Gemini response, but it's empty because we don't have an API key, but we'll get to that later. So if we head to the task tab over here, we see that there's nothing here. If we add a task, all this UI is written, so boom, but it actually doesn't do anything. So we need to actually code this to-do list component. So we can go ahead and do that. So if we head to pages, we open up pages, we open up task page, we can see that we scroll down, we can see that there's a to-do. So we want to implement the task component. We can see right here, it's not actually returning anything, it's just returning an empty box. So we can go ahead and work on that together. So just before we work on it, we can go through kind of how it's structured. So we have the scaffold here, which is kind of the page itself. We have the app bar, which is to-do list, and we can see that up there. And then we have the body. So the body is a builder, which has a context. This context is passed into the provider, which is basically a global state management for Flutter. So we can access the to-do controller given a context. And this context is passed all throughout the Flutter app. This to-do controller has all the code already written for handling the to-do list. So we can see here that there's a list of to-dos, and when it's initialized, it loads the to-dos, it saves the to-dos to storage. The add to-do adds it to the list and saves it. Same with the delete, it removes it from the list and saves it. Update finds that entry, updates it. So all this stuff is written for you, and you can take a look at this whenever you want. But yeah, it basically everything's provided for us, courtesy of me. Okay, so then we can access the to-dos by using the controller over here, dot to-dos. So we can see that if we go into the to-do controller, the to-dos over here returns the to-dos that are associated with this class. And if it's empty, we want to return no to-dos available. Otherwise, we return an animated list. So this implicitly animated list is an external package that animates changes for us. We don't have to worry too much about that. We just have to worry about our item builder. So our item builder has the to-do passed in. It is of type to-do. And if we go ahead and look at that, so if we go to the to-do controller, we go to to-do, we can see the format of the to-do. So it has an ID, a date created, a name, and if it's completed or not. So these are some of the stuff that we can kind of show in the UI. And that kind of brings us to over here. So we have our task component. There are a few actions we want to code in. So we want to code an update, delete, and a completion. We want to display maybe the name, the date, and the completion status. So let's go ahead and go back here. So our to-do is passed in here, and now we can start actually making the UI. So we will start with a list tile. So again, this is all built in the Flutter UI library, so all this stuff is for free. We can go ahead and also add a key so that the implicitly animated list knows when to actually animate things. And this is of type value key. And then this would be the ID of the to-do. Okay. And then within the actual list tile, we get a few other parameters over here. And these are all, again, built in the UI of Flutter, and we can control space to get the autocomplete within Visual Studio. Let's add a subtitle and a text widget and with the to-do name, to-do.task name. All right, so if we go ahead and save this, we can see that our UI is already starting to come together. There are 3 to-dos here, test, hello, and test. And let's go ahead and add the title. So text. And actually, let's make the title the task name. And let's go ahead and make the subtitle maybe the date created. And we need to convert that to a string. So we go ahead and save that. Our UI is already starting to get a bit better. Let's go ahead and make it so the trailing component of the list tile is a checkbox, which again, checkbox is all added in Flutter by default. The value of the checkbox would be the to-do if it's completed. And we also want to add in on changed. Basically, when the checkbox is changed, we want to check off the to-do. So to-do controller. Let's go ahead and make a function here. Sorry, I'm going to put down the mic for a second. All right, so we made a function here. So onChange passes in the value, which is a bool. And then we want to update to the controller, which is defined up here. And we want to update the to-do. We want to take this to-do. We want to copy with. And we want to set is completed to this value. Now, I know this kind of seems like a lot kind of happened all in one go, but after we're done, I'll review kind of all we've written so far. So if we save this, again, one of the perks of Flutter is that everything changes instantly over here, and we can see that. And now, since we added an onChanged, we can go ahead and actually check off something, and it will automatically go to the bottom. And we can uncheck, and we can see that everything animates very smoothly. And again, all the logic of the to-do list is already written in the to-do controller, which you are free to look at any point. Cool. Now let's maybe make it so that if we tap the to-do, we're able to edit that to-do. So we can go ahead and for the list tile, add an on tap, which again is a function. And then we already have a function called show edit to do bottom sheet, which we can control click to see all the logic of that if we need to, which is just further down on that page. We can see that it opens a bottom sheet with an edit to do. And when it submits, it gets that instance of the to do and changes the task name to whatever was entered. So we can go ahead and look at that code at a later point in time. And then the show edit to do bottom sheet takes in a context because we actually have to call this function and it takes in the to do that we want to edit. And again, this to do is part of the item builder. So that's related to whatever to do is here. And if we save that and we tap this, hello, we can see that hello is here. And then we can edit that to do over there. And it changes. We can get this one, we can call it testing. And it changes the one according. Cool. So now the only thing we're missing is the delete. So we can't really delete the actual to do, but maybe if we long press the to do, we'll delete it. So again, it's a function and we will take the to do controller. We will delete a to do and this function takes in the ID of the to-do. So to-do.id. Save that, and if we long press this, it'll delete it. You can check it off, and everything animates all nicely. Cool, so our to-do list is starting to come together. Let's go through kind of the code that we've written so far. So again, this is a task page, and it is a stateful widget. So that means it has state. We don't actually use state right now, but it can have state. We return from the builder a scaffold, which is the entire page. Scaffold takes an app bar. The app bar over here, to-do list. We can change this to anything we want. You can see updates over here. This icon button runs the show add to do bottom sheet, which again, all the code is already written for us, which pops up everything that we can use to add to dos. In the body, that's what's actually shown on this page. We have our animated list, which item builder, we have our to-dos here, and our item builder, the actual to-do. And we return a list tile. So all this code is what we've written. So each list tile takes a key, a subtitle, a title, and we can set these to whatever parameter we want of the to-do. When we long press, we take that to-do controller, we delete it. When we tap it, we open that editing bottom sheet. Again, that function was written for us. And the trailing component is the checkbox that updates the status of that to-do. Cool. Are there any questions about what we've written so far? Yeah. Yeah, that's a great question. So the question was, is there anything that's kind of Flutter specific to this, or is this just front end? So this is kind of both. So this is shows you the power of Flutter's front end. So we can see that list tile and like kind of everything that we used here, like checkbox and text, is part of the component library that's built in Flutter. We also see that the to-do controller is all updated accordingly based on the kind of global provider of it. So it's like, I don't know if you've heard of Redux in React. So it's kind of like a global state management system that makes everything really easy for us to update the UI accordingly when something changes. So that kind of shows you the power of Flutter. Also, the animations are all kind of done for free for us because, again, it's a game engine. So we can animate however we want and not really care about performance or need to do anything special. It kind of all comes for free with the Flutter engine, which is pretty cool. And yeah, so it's a kind of a bit of both. It's front end and also shows you the power of Flutter itself. Okay, so now let's go back to the slides. So we did the to-do task component. Now we will work on the Gemini list summary. So if we go to homepage, we can see that we don't have anything yet. So that's okay. Let's go ahead and get an API key. So in main.dart, we can see that there's a to-do over here. There's a link that we can click to get an API key. So I have it open over here. So all we have to do is just get an API key. It's very simple to do. And we got an API key. We can go ahead and paste that here. Save this. We might need to do a hot restart instead of a hot reload because stuff in main only runs once when the application's loaded. Okay, so now that our API key is set up, we can go ahead and actually return an analysis of our to-do list. So if we go to the to-do controller, we can see that there's another to-do at the bottom here, a lot of to-dos. We want to actually call a generation from the Gemini API. So we have our Gemini instance over here, and we can go ahead and return our response. We can go ahead above that, declare a new string, which can be nullable. So the Gemini API we have over here, text, and let's say create a summary of the to-do list. And then we can add the to-dos to string. Okay, and then we want to get the output of that. Because this is an asynchronous function, we need to make sure that that runs first. So we will put that in brackets. Okay, cool. So now if we do a reload, let's see if this works. It's not working. That's okay. Let's see what's wrong here. Oh, right. So there's one more to do we have to do. So we want to actually display the analysis. So we're going to learn a bit about state in Flutter. So for those of you who aren't aware of kind of how front end usually functions in, for example, React, everything has a state. So state is something that can change, but when we set state, everything will re-render, which can be very inefficient. So we want to be careful about how we set our state. But in this case, we need something to change. So after we get an analysis, we need it to show in the actual UI. So in order to do this, we will call the analyze to-do list. So to do this, we need to get our to-do controller from our global state management, which is the provider. So it's the provider of context, but it's of type to-do controller. And we want to get that. But we want to set listen to false. And the reason why we want to set listen to false is because this is a function. This function runs once and it gets an instance of it. So we're not actually listening to changes when we run this function. So we need to set listen to false. If we forget to do this, it'll throw an error and it'll tell us what's wrong. And then we want to get the actual analysis. So string output, and we will await on this. So to do controller instance. And this was the function we just ran, and we can control click this and see that this is the function that we just had, just implemented. All right. And then we want to set the state. So analysis, which is declared up here, equals out. Run that. Let's go ahead and do a little restart here. Okay, cool. So we get an output now from Gemini, and it's not really the cleanest, but if we tap the stars here, we can regenerate an output. But let's go ahead and do some prompt engineering. Create a summary of the to-do list and make it funny and 2 sentences. So we can save that, get a new one. All right. And then we can add a to-do here. And we can go ahead and regenerate a summary. And we can see that it makes a funny joke from Gemini. So cool. So now we've implemented Gemini. We've added the task component over here. We have kind of a full functioning app. And for those who are curious, to go back to the repo here, if we switch branches to complete and we go to the changes here, we can see that everything we coded today is all accessible here if you need to quickly copy paste or want a kind of complete app here. The only thing that's missing is the API key won't be here. Yeah. Yeah, so that's a great question. The question was, right now we're running actually in Android, but if we were to run it on iOS, do we have to change anything? The answer is no, we don't, because all the code we've written so far is Dart code, and Dart code is specifically multi-platform. So everything that we've written right now works on both iOS and Android. And actually, I can pull up iOS as well right now and see it working. So let's do that. Go ahead and close this. So we can open up the workspace in Xcode. So we need to make sure we have Xcode installed. It's in the iOS folder. Sometimes Xcode takes a while. Okay. And we also want to make sure we install dependencies. So go ahead and do that. We can hit the play button. And we can also do this within Visual Studio Code as well. Now we have an iPhone running. It's installing. There it goes. Let's see if it works or if there's something wrong. There we go. And everything we coded is all here. Which is pretty cool. All right. So that's the power of cross-platform app development. Cool. So we added a prompt, added our API key, and we're able to generate a summary of the to-do list. All right. So just to wrap up the workshop, let's talk a bit about mobile user interfaces. So a good design makes an app attractive to use, which is pretty important because we want people to use our app. So mobile user interfaces, we want to design them in a way that are built for one hand. So we want to make sure that we have reachable areas within our application. Also animations and continuity. Flutter makes it easy to add animations, and we want continuity when you navigate across different pages. We want to ensure that there's intuitive motion and gestures and also a responsive design. So for example, with folding phones nowadays, who knew that we would have to support a square interface, but that's kind of the cool world we live in. So we want to make sure that we have a responsive app as well. So this is one of the applications that I made. So we can see here that the top area is kind of just blank space. And that kind of pushes down all the other UI elements so that it's easier to reach without sacrificing kind of the design. We can see that the important action is easily reachable over here in the bottom right corner with the thumb, and the navigation at the bottom here is also reachable. And here we have another page again. So we're just using this blank space to show information, kind of areas you don't tap much, and then pushing the important things down. All right. Any questions so far? Yeah. The recording? I can let you know after where the recording will be posted. Cool. All right. Scalability. So this is the last topic. How to bring an app to production. So scalability is usually important in hackathons. They usually ask you, the judges will ask you, how would you kind of scale your idea or application? And within mobile applications, it's kind of a bit different. So we want to make sure that we have scalable cloud services. So kind of everything uses the cloud nowadays. More users, more load, more resources, and more costs. So we have to be careful about that. We want to kind of take advantage of local processing and storage. So I don't know if you've heard, but the new iPhones kind of do a lot of processing for AI on the device itself. And I'm sure Apple's pretty happy about that, cutting the costs of their cloud services and kind of getting all the cloud computing. Everything happens on the user's phone itself, and the user charges their own phone, they use their own battery, and I'm sure Apple was very proud of accomplishing that. Also, we can use personal cloud. So, for example, Google Drive is an example of personal cloud, and the user owns their data on Google Drive, and also they pay for their storage themselves. So as a developer, we don't actually sacrifice any of our resources when we use those APIs. Everyone has a phone as well, and we want to make their phone into a useful tool. And I think that's why I kind of love app development, because phones can be really useful. All right. So here is some statistics from one of the applications that I made. This is the Google Drive API, which is 100% free for me. But we can see that if it did actually cost me money, it would cost a lot of money, because this is over a month. There's 1.4 million requests for the creation API for Google Drive, and 1.8 million for listing files. And again, because this is personal cloud, it doesn't cost me anything. It costs the users instead, because they pay for their own storage. And I'm sure Google is happy that developers use their API, because then it encourages other people to sign up for Google. And that brings us to the end of the workshop. If you have any questions, feel free to stick around. And I'm here to help you out with anything. Doesn't even need to be specific to this workshop. And yeah, that's it. Thank you.